Your test tomorrow is on sections 3.1 to 3.5. Your review is very similar to your test. Your test is not hard. It makes you think, like I said yesterday, but it is not hard. As long as you know what you are doing and you are confident with what you are doing, you will not have a problem. Your first question, you have a function that's given to you, which is 2x squared plus 7x minus 4. It asks you which way it opens, what your vertex is, what your maximum or minimum is, meaning the value and whether or not it's a maximum or minimum, what the domain is, what the range is, your x-intercept, your y-intercept, and you need to add in your axis of symmetry, because that's one of your questions as well. So it's not there, but add in the axis of symmetry. Given this function, your a term is the 2, your b is the 7, and your c is 4. A is 2, b is 7, c is negative 4, I'm sorry. Because this 2 is positive, this parabola opens up. From here, you need to find your vertex. So remember, h is your x value, which is equal to negative b over 2a. K is your y value, which is equal to c minus b squared over 4a. So we said your a is 2, your b is 7, your c is negative 4. To find h, that's going to give you the opposite of 7 over 2 times 2, which is negative 7 over 4. That's your x value. That's also your axis of symmetry. So x is equal to negative 7 over 4 is your axis of symmetry. I would write that down so far, so that way you don't have to worry about doing that later on. For your y value, or k, you have c minus b squared over 4a. This c is your negative 4, minus b squared is 7 squared over 4 times a, which is 2. That gives you negative 4 minus 49 over 8. That negative 4 has to turn into something over 8. So that's going to give you k is equal to negative 32 over 8 minus 49 over 8. The negative 32 and the negative 49 are they have same signs, so keep the sign and add the numbers. So this is going to give you a k of negative 2 plus 9 is 11, carry the 1, 81 over 8. So your vertex is the ordered pair, negative 7 over 4, comma, negative 81 over 8. That k value also gives you your maximum or your minimum. We said that this parabola opens up, which means you're going to have a minimum value, and that minimum value is going to be at y is equal to negative 81 over 8. You have to give that y is equal to tomorrow. Your domain, since this is a parabola, automatically it's all real numbers. So from negative infinity to positive infinity. Your range has to do with the y value from your vertex. So this parabola opens up, it's going to go to positive infinity. The lowest value is going to be that negative 81 over 8, which is included. So we'll have a bracket on the negative 81 over 8, comma, positive infinity, with the parentheses on that. Your y-intercept is the easiest to do out of the two, x or y, because it is part of your c value. Whatever your c is, it gives you your y-intercept. So that's 0, comma, c. So your c value is negative 4, so that's 0, comma, negative 4. To find your x-intercepts, you need to take the 2x squared plus 7x minus 4 and factor it and solve for x. It's your zeros. So if we take this 2x squared plus 7x minus 4 and we set it equal to 0, we factor it. The 2 times negative 4 is negative 8. The factors of negative 8 that add up to be positive 7 are negative 1 and positive 8. So this factors or gets rewritten as 2x squared minus x plus 8x minus 4 is equal to 0. We can factor this by grouping. We factor out an x from the first set. We factor out a positive 4 from the second. So this just gives us x times 2x minus 1 plus 4 times 2x minus 1 is equal to 0. Your two parentheses are the same, so we can rewrite this as 2x minus 1 times x plus 4 is equal to 0. From here, set each of these equal to 0 and solve for x. For the 2x minus 1 is equal to 0, add your 1 to both sides. You have 2x is equal to 1. Then divide each side by the 2, and x is 1/2. So that gives you the ordered pair of 1/2, 0. For the x plus 4 is equal to 0, subtract your 4 from both sides. That gives you x is equal to negative 4, which gives you the ordered pair, negative 4, 0. So the two ordered pairs that are your x-intercepts are this 1/2, 0, and the negative 4, 0. For the next part, you're asked for the ending behaviors. Remember, these are the ones that are as x goes to negative infinity, y goes to where, and as x goes to positive infinity, y goes where. So the first parts of these are always going to be the same. The x goes to negative infinity, x goes to positive infinity. Then it's y goes where for both. Remember with these, you're looking at not only the power, but also your a term. So make sure that these are in standard form first, then look at the highest power. The highest power tells you what type of graph this is. If it's an even power, so 2, 4, 6, 8, so on, it's going to be a parabola, so it looks like a U. If your a is positive, it opens up. If your a is negative, it opens down. If your power, highest power, is an odd number, so 3, 5, 7, 9, so on, it's going to look, or it's going to go up one way and down the other. If your a is positive and you have an odd power, it goes up to the right, down to the left. If your a is negative and it's an odd power, it goes up to the left, down to the right. So looking at number 3, you have f of x is equal to negative 2x to the 4th power plus 7x minus 1. It's in standard form. The power on that is even. It's 4, so it's going to be a parabola. Your a, however, is negative, so this parabola opens down. So these are both going down, so y is both going to negative infinity. So when you give your answer, your x is going to negative infinity as your y goes to negative infinity, and your x goes to positive infinity as your y goes to negative infinity. For number 4, you have f of x is equal to 5x cubed minus 5x minus 1. Again, this one's in standard form. So this one I'm going to do a little different than I did with 3 because I'm going to do it with the name of the function as well as the falling left, falling right, or rising left, rising right kind of thing. So this one, odd power, a is positive. It's going to go up to the right, down to the left. So with this one, you are going, or rising to the right, falling to the left. So that might help you when you give your answer. So you can use the y or you can use the name of the function. In this case, it is f of x, so we can also write this as x goes to negative infinity, f of x goes to, so as x goes to the left, we said that it's falling left, so that would go to negative infinity. And then as x goes to positive infinity, so if it goes to the right, f of x goes up, so it goes to positive infinity. For number 5, we have f of x is equal to negative 2x to the 5th power plus 4. For this one, we have an odd power, but our a is negative, which means our graph is going to go up to the left, down to the right. So if you want to say that this is rising left, falling right, you can. And then you just give as x goes to negative infinity, f of x, or y, goes to, so as x goes to the left, y goes up, f of x will go to positive infinity. Then as x goes to positive infinity, so to the right, your f of x, or y, goes to negative infinity. For your next part, you are finding the zeros and the multiplicity if there is any. For number 6, you have f of x is equal to 3x cubed minus 21x squared plus 36x. You're going to set this equal to 0 and solve for x. If you factor out the greatest common factor first, your greatest common factor is 3x. So this is going to give you 3x times x squared minus 7x plus 12 is equal to 0. Your factors of 12 that add up to be negative 7 are going to be negative 4 and negative 3. So that's going to be 3x times x minus 4 times x minus 3 is equal to 0. Now that you're completely factored, set each part equal to 0 and solve. So you're going to have 3x is equal to 0, x minus 4 is equal to 0, and x minus 3 is equal to 0. Solve each of these for x. Divide each side by the 3, and the 3x is equal to 0. You get that x is 0. Add your 4 to both sides, and the x minus 4 is equal to 0. You get that x is 4. And then add your 3 to both sides, and the x minus 3 is equal to 0. So you get that x is 3. So your zeros from here, your answers, your solutions, are 0, 4, and 3. You can give them to me just like this. So x is equal to 0, x is equal to 4, x is equal to 3. Or if you want to write them as x is equal to the set of numbers 0, 3, and 4, you can. It's up to you. The multiplicity on this one is none because none of your answers repeat. If they did repeat, then you would have the multiplicity. But in this case, you have none. For number 7, you have f of x is equal to x cubed minus 2x squared minus 4x plus 8. For this one, you do not have a greatest common factor that you can factor out. So factor by grouping since there's 4 terms. You're going to set this equal to 0, put parentheses around the first 2, put parentheses around the last 2. The first 2, your greatest common factor is x squared. The last 2, your greatest common factor is the negative 4. So this gets rewritten as x squared times x minus 2 minus 4 times x squared, x minus 2 is equal to 0. Your 2 parentheses are the same, so this gives you x minus 2 times x squared minus 4 is equal to 0. You can still factor the x squared minus 4. I would factor it. The reason why is because on your quiz, a lot of you didn't factor it and then thought that you had a multiplicity because you have an x squared. That's not the case. If you factored this, it gives you x minus 2 times x minus 2 times x plus 2 is equal to 0. In this specific question, you will have a multiplicity because you have that x minus 2 twice. However, if it was just x squared minus 4 is equal to 0, that x squared minus 4, if you moved that 4 over and took the square root of both sides, it's x is equal to plus or minus 2. The plus or minus 2 does not occur more than once for just the x squared minus 4. So for this one, from here, you set each of these parentheses equal to 0 and you solve. So x minus 2 is equal to 0, x minus 2 is equal to 0, x plus 2 is equal to 0. Move your 2 over, move your negative 2 over. Add your negative 2 to both sides. You get x. Here, let's do this in a different color so you can actually see. Add your 2 to both sides. You get x is equal to 2. Same thing with this one. And then with this one, you subtract the 2 from each side and get that x is negative 2. So if you want to just give me x is equal to 2, x is equal to 2, x is equal to negative 2, that is fine. If you would rather give the zeros as x is equal to the set of numbers negative 2 and 2, you can do that as well. For this one, because that x is equal to 2 twice, you have a multiplicity of 2 at x is equal to 2. For number 8, you have f of x is equal to 3x squared minus 10x minus 8. This one, you cannot factor it just by what are the factors of 8 that add up to be. You can't do that. You have an a that's something other than 1. So you have to multiply your a and your c terms. That 3 times negative 8 is negative 24. Your factors of negative 24 that add up to be negative 10 are 2 and negative 12. So you're going to rewrite this as 3x squared plus 2x minus 12x minus 8 is equal to 0. And factor this by grouping. If you set the two sets or the two terms in the front within parentheses and the last two in a set of parentheses, you are going to factor out an x from the 3x squared plus 2x and a negative 4 from the negative 12x minus 8. From here, this is going to give you x times 3x plus 2 minus 4 times 3x plus 2 is equal to 0. Your two parentheses are the same, so that gives you 3x plus 2 times x minus 4 is equal to 0. Set them both equal to 0 and solve. For the 3x plus 2 is equal to 0, you're going to subtract 2 from both sides. You get that 3x is equal to negative 2. Then you're going to divide each side by the 3, and you get that x is negative 2/3. For the x minus 4 is equal to 0, add your 4 to both sides, and you get that x is 4. So again, if you want to just highlight these or circle them and give that x is equal to negative 2/3, x is equal to 4, you can do that. If you would rather write it as zeros or x is equal to the set of numbers negative 2/3 and 4, you can do that. Do either of these numbers, these zeros, repeat themselves? No. So your multiplicity is none. For number 9, it tells you to use long division to solve. You have 2x squared minus 7x plus 11 over 2x minus 5. That 2x minus 5 is going to go on the outside. The 2x squared minus 7x plus 11 goes on the inside. Remember, with your division, you have to have every power from the highest to the lowest represented. You have the highest power here as a 2, you have x to the power of 1, and then your constant. So you're good. The 2x times what is 2x squared? Just x. So x times 2x is 2x squared. X times negative 5 is negative 5x. You subtract these or add the opposites. The 2x squareds cancel. Negative 7x plus 5x is negative 2x. Drop the 11 down. Then you ask yourself, 2x times what is negative 2x? It's just negative 1. So negative 1 times 2x is negative 2x. Negative 1 times 5 is positive 5. Subtract these or add the opposites. So the 2x's cancel. 11 minus 5 is 6. This gives you a final answer of x minus 1 plus 6 over 2x minus 5. For number 10, it tells you to use synthetic division to solve. You're writing your answer as a polynomial. We have 2x cubed plus 12x squared minus 6x plus 3 divided by x minus 2. Remember with these, it's going to give you the x minus 2, but you got to solve for what x is. So set that x minus 2 equal to 0, add your 2 over, you get that x is 2. So the 2 goes in your box. You have x cubed, x squared, x, and your constant. So every power is represented. You're going to have the 2, the 12, the negative 6, and the 3 on the right side. Drop down the first term, which is 2. Multiply it by the number in the box. 2 times 2 is 4. Add it with the 12, that's 16. 16 times 2 is 32. Add it with the negative 6, that is 28, no, 24. 24 times 2, is it, oh, I'm sorry, 26, thank you. 26 times 2 is 52, plus 3 is 55. So that 55 is going to be your remainder. The 26 is going to be your constant. The 16 is your x, the 2 is your x squared. So this gives you an answer of 2x squared plus 16x plus 26 plus 55 over x minus 2. For 11, it tells you to use your remainder theorem. P of -3 is what you're using to find, or sorry, you're finding P of -3, which means the -3 is going to go in your box. You have -2x to the 6th power plus 9x to the 5th power plus 44x to the 4th power minus 6x squared plus 14x plus 113. For this one, you're missing the x cubed. So if you want to plug in the plus 0x cubed, you can. That'll tell you to put the 0 in for that place. So on the right of this -3, you're going to have -2, 9, 44, 0, -6, 14, and 113. The -2 drops down. -2 times 3 is 6, plus 9 is 15. 15 times -3 is -45. Add that with the 44, that's -1. -1 times -3 is 3. Add it with the 0, that's 3. 3 times -3 is -9. Add it with the -6, that's -15. -15 times -3 is positive 45. Plus 14 is 59. Times -3. 9 times 3 is 27. Carry the 2. 5 times 3 is 15. Plus 2 is 17. It's negative. Subtract the 2. 7 minus 3 is 4. 7 minus 1 is 6. It's negative, so -64. So P of -3 is equal to -64. For number 12, you're asked if x minus 3 is or is not a factor of P of x. So your 3 is what's going in your box. P of x is x cubed minus 4x squared plus 4x minus 3. All your powers are there. So you're going to have a 1, a -4, a +4, and a -3 to the right of that 3 in your box. The 1 drops down. 1 times 3 is 3. Add that with the -4. That's -1. -1 times 3 is -3. Add that with the 4. That's 1. 1 times 3 is 3. Add that with the -3. That's 0. Your remainder is 0. So x minus 3 is a factor of P of x. For number 13, 15, 16, and 17. I guess we're skipping 14. It's okay though. We have to use the rational root theorem to solve. So we have for number 13, f of x is equal to x to the 5th power plus 5x cubed minus 14x. We don't have a constant here that we can find the factors of in order to use the rational root theorem. So we're going to factor out the greatest common factor first. So we could set this equal to 0, then factor out the greatest common factor, which is x. That gives us x times x to the 4th power plus 5x squared minus 14 is equal to 0. I'd rather factor this one because you can actually factor it. Your factors of -14 that add up to be 5 are -2 and +7. So this factors out to be x times x squared minus 2 times x squared plus 7 is equal to 0. From here, you'd set each of these equal to 0 and solve them because they are not the difference of squares. So x is equal to 0, x squared minus 2 is equal to 0, and x squared plus 7 is equal to 0. For the x is equal to 0, that's a solution. Highlight it so you know that's an answer. The x squared minus 2 is equal to 0. Add your 2 to both sides. You have that x squared is equal to 2. Then take the square root of both sides. So x is equal to plus or minus the square root of 2. X is by itself there. So highlight that one. Then finish the x squared plus 7 is equal to 0. Subtract your 7 from both sides. You have that x squared is equal to -7. Take the square root of both sides. You got that negative. You also got to put that plus or minus there. So x is equal to plus or minus I square root 7.
Can you use a quadratic formula for that?
Yes, you could. You'd have to still, well, not really, no, because it's an x to the 4th power, not x squared. If it was x squared, then yes, you could. Are you still going to get the same answer? Yes, but it would be a little bit different. For 15, you have x cubed plus 5x squared minus 24x, or sorry, minus 2x minus 24. Your constant is the 24, so find the factors of 24. You have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. I'm going to start with 1. My terms to the right are going to be 1, 5, negative 2, negative 24. The 1 drops down. 1 times 1 is 1. Add that with the 5, that's 6. 6 times 1 is 6. Add that with the negative 2, that's 4. 4 times 1 is 4. Add that with the negative 20. 4, that's negative 20. That does not give you a 0 for a remainder, so that's not your answer. Try 2. You're still going to have the 1, the 5, the negative 2, and the negative 24. The 1 drops down. 1 times 2 is 2. Add that with the 5, that's 7. 7 times 2 is 14. Add that with the negative 2, that's 12. 12 times 2, 24. Add that with a negative 24, that's 0. That's an answer. Now use the 1, the 7, and the 12. That 7 gets an x, that 1 gets an x squared. So you're factoring x squared plus 7x plus 12 is equal to 0. Your factors of 12 that add up to 7 are 3 and 4. So x plus 3 times x plus 4 is equal to 0. Set them both equal to 0 and solve. You're going to have x is equal to negative 3, x is equal to negative 4. So you have 3 solutions here. X is equal to 2, x is equal to negative 3, and x is equal to negative 4. If you want to give the solution set instead, you can do that also. It's totally up to you. For 16, you have x cubed minus 7x squared plus 16x minus 12. Your constant is negative 12. Your factors of negative 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. If we start with the 1, you're going to have 1, negative 7, 16, negative 12. 1 drops down. 1 times 1 is 1. Add that with a negative 7, that's negative 6. 6 times 1 is negative 6. Add that with the 16, that's 10. Times 1 is 10. Add that with the 12, that's negative 2. That 1 is not an answer. Try 2. Again, you have... What? So that 1 drops down. 1 times 2 is 2. Add it, that's negative 5. 5 times 2 is negative 10. Add it, that's 6. 2 times 6 is 12. Add it with the negative 12, that's 0. So the 2 is your answer. You also have the constant of 6. 5 gets an x. 1 gets the x squared. So you're factoring out x squared minus 5x plus 6 is equal to 0. This factors out to be x minus 2 times x minus 3 is equal to 0. So that means that x is equal to positive 2, x is equal to positive 3. So your solutions for this are x is equal to 2, x is equal to 2, and x is equal to 3. If you only wanted to write that x is equal to 2 once, you could. You would just then have to tell me that you have a multiplicity of 2 at x is equal to 2. For number 17, you have x to the 4th power plus 20x squared plus 75 is equal to 0. I'm going to factor this one only because I can. The 75 has factors of 3 and, or sorry, not 3, 5 and 15, which give you 20. So this is going to factor out to be x squared plus 5 times x squared plus 15 is equal to 0. This then gives us x squared plus 5 is equal to 0, and x squared plus 15 is equal to 0. Move your 5 over, subtract it from both sides. You get x squared is equal to negative 5. Take the square root of both sides, so x is equal to plus or minus I square root 5. That's 2 of your solutions. Finish them out. X squared plus is equal to negative 15. Take the square root of both sides. X is equal to plus or minus I square root 15. That's another. For number 18 and 19, finding the polynomial function with the real coefficients that has the given zeros. So for 18, we have that x is equal to 7, x is equal to negative 2, and x is equal to 4. If we solve each of these for 0, we're just going to move the 7 over by subtracting it from each side. So x minus 7 is equal to 0. The x is equal to negative 2. We're going to add the 2 to both sides. So we have x plus 2 is equal to 0. And the x is equal to 4. We're going to subtract the 4 from both sides to get x minus 4 is equal to 0. We're going to take each of these 3, put them in parentheses, and FOIL them out. So x minus 7 times x plus 2 times x minus 4. The x times x is x squared. The x times 2 is 2x. Negative 7 times x is negative 7x. And negative 7 times 2 is negative 14. You are still multiplying this with the x minus 4. So combine your like terms of the 2x and the negative 7x. That gives you x minus 4 times x squared minus 5x minus 14. You are then going to multiply this x in, so x times x squared is x cubed. X times negative 5x is negative 5x squared. X times negative 14 is negative 14x. From here, the negative 4 gets distributed in, so negative 4 times x squared is negative 4x squared. Negative 4 times negative 5 is positive 20x. And negative 4 times negative 14 is positive 56. So we add these up, and we get x cubed minus 9x squared plus 6x minus 56. For number 19, we have x is equal to 2/3, x is equal to negative 1/4, and x is equal to 6. So this x is equal to 2/3, I'm going to multiply each side by 3. That cancels out the 3 in the denominator, so I have 3x is equal to 2. Then I subtract the 2 from each side, and that gives us 3x minus 2 is equal to 0. For the x is equal to negative 1/4, I'm going to multiply each side by 4. That 4 in the denominator cancels out, so we have 4x is equal to negative 1. We add the 1 over, so 4x plus 1 is equal to 0. And then the x is equal to 6. Subtract your 6 from each side, so x minus 6 is equal to 0. So we are going to multiply 3x minus 2 times 4x plus 1 times x minus 6. The 3x times 4x is 12x squared. 3x times 1 is 3x. Negative 2 times 4x is negative 8x. And negative 2 times 1 is negative 2. This, again, is still being multiplied by that x minus 6, so don't forget about that. Combine your like terms. You're going to have x minus 6 times 12x squared minus 5x minus 2. So start distributing the x in. X times 12x squared is 12x cubed. Then x times 5x is negative 5x squared. X times negative 2 is negative 2x. Then do it with the negative 6. Negative 6 times 12x squared is negative 72x squared. Negative 6 times negative 5x is positive 30x. And negative 6 times negative 2 is positive 12. So if we add up our like terms, this gives us 12x cubed minus 77x squared plus 28x plus 12.